Okay, so great. So recording has started. So hello everyone. I'm Lakshya Sagli. We are meeting for the first time. So I'll be your TA for NPTEL Discrete Maths Course. So like this is the first week of the problem solving sessions for NPTEL. So we'll start a little bit slow and cover the concept which you may already know from earlier. But like just bear with me because I think that you should try to like understand the basic concept first, and then we can delve into the later concepts in the later weeks. So we'll just start with the basics of counting and uh, yes, Jashoda, you will get the recordings. We'll be uploading these recordings on YouTube, so you guys can access those recordings later also. So yeah. So we'll start with some basic problem solving. So let me just share my screen first. Just a second, guys. Share, share, share. Yeah, great. So can everyone see the Google Docs, the screen which I've shared? Can someone let me know in the chat or by thumbs up if they can see my screen? Nice. So you guys can, yeah, you guys can see the screen. Nice. Uh, no, I don't think there are any lecture attendance marks. There are just these lectures are just for helping you guys understand the concepts better. Okay. So let's start with the problem solving session. So I don't have a tablet as of now. Hopefully it will come in a couple of weeks. So today we'll be solving the problems on Google Docs only. Okay, so bear with me guys. So let's start with the first problem, I guess. So basically I have some problems clubbed together from previous year assignments related to week 1 and week 2. In week 1 we'll be covering the problems related to counting, and week 2 will be the set of problems which will be related to sets. So yeah. So let's first start with the counting. So you may find these problems very trivial, but I guess we should we should know the basics of counting before starting with other concepts of discrete maths. So let's start up, guys. So first question is, as you can see, in how many ways the word pathogen can be arranged such that the letter O always comes to the left of K? So just to introduce, what we can say is this is like a very trivial question, but I'll just still write it out. So in any permutation for pathogen, basically there are two cases in any permutation. There will be two cases. Either O comes to left of K or K comes to left of O. So these are the only two cases which can occur. So we can see that both these cases are sort of identical in the sense that the number of cases in which O will come to the left of K and K will come to the left of O will be equal, because all the other letters can be arranged in the same way, right? So basically, so we can say, let's say number of required permutations is X. And we know the total number. What are the total number of permutations for pathogen? It's straightforward, but we'll still count it out. So pathogen contains 8 distinct words, right? 8 distinct characters. So total number of permutations also depends on, as you may have seen the lectures also, total number of permutations also depends on if the characters are distinct or some are same characters. So here P, A, T, H all are unique characters. So this implies that there will be total 8 factorial permutations. So basically these 8 factorial permutations will be, there will be two cases. in each of these 8 factorial permutations, either O will come to the left of K or K will come to the left of O. So we can just say that like X is the case that O comes to the left and X is the case where O comes to the right. So X plus X will be equal to 8 factorial. So this implies that X is, so basically this says that 2X equals to 8 factorial. So the value of X will be equals to 8 factorial divided by 2. So yeah, pretty straightforward question, I would say. This is the answer. X is equals to 8 factorial. Maybe I'll just in chat. Okay, I think I miss. I wrote it as K. Sorry. Yeah, there is no K. I just realized. Sorry. Let's say it's any other word. Like it doesn't matter much what word we are talking about since all the words are distinct. So in any like you can say O either comes to the left of T or T comes to the left of O. Yeah, yeah, guys, I understand that there is no K. So maybe I messed up a little bit while writing the problem. So you can just assume instead of K, it was T. So we just had to show like we just had to count like O comes to the left of T, T comes to the left of O. So I guess this is pretty straightforward. Yeah. So from this, X comes out to be 8 factorial by 2. One thing I wanted to point out in this was that see here the question was in how many ways the word pathogen can be arranged such that the letter O always comes to the left of T, right? There here the word was comes to the left. Suppose the question was comes to the immediate left. So like I'm just saying that maybe we'll try to twist this problem a little bit because like if we understand the basic problem, then we can also try to understand a little bit a little bit twisted problem so that like this will help in our understanding, right? So we can sort of say, suppose the question was instead of this, suppose the question was, I'm just doing this for better understanding, comes to the immediate left of T, right? So here, how can we solve? This is also something which you guys may know about. So would anyone want to type its solution in the chat, or should I just go about discussing this? Like you understand the difference in these two, right? So O comes to the left of T. Here it means that something like this can also occur, like some pattern like this OPT. This sort of pattern can also occur. But comes to the in immediate left, only the cases which we have to count are where O and T occur together, and all the other words can be permuted around these. So here the answer is pretty simple, I would say. This sort of thing you have also done. So basically, we'll create a group of O and T, and this group should always be together in any permutation, right? So since this group is together, the other words, let's say P, A, H, G, E, and N. So all of these words can then be permuted in any way along with this group. Only this group has to remain together, this O and T group, and everything else can be permuted together. Yeah, the answer would be, yeah, the guys in the chat are correct, but I'll still spell it out for you guys. So since there are now 7 groups, the N, the E, the G, the H, the A, the P, and O and T. So these can be permuted in any ways, and we'll always get the case that O always comes to the immediate left. So in this case, the answer would be we have to permute these 7 groups around each other. So the number of permutations would be 7 factorial. So yeah, many guys were saying 7 factorial in the chat, which was correct. So the main idea involved here is this only, that like if it was just comes to the left, then we just say that the counting was a bit different. In if it just comes to the left, then we just have to find the total number of permutations, and in some cases O will be to the left and O will be to the right. So those cases will be symmetric. So we just divide by 2. But here, if it comes to immediate left, then there is no like straightforward answer, like we'll just divide by 2 or anything, because we have to create this grouping of O and T together. So here the answer is like we group O and T together and we get 7 factorial. So yeah, pretty straightforward, but I would say like still necessary. So yeah, so first question is done. So let's come to the second question now, guys. So the second question says that Rahul has 7 differently colored shirts, 5 different jeans, 2 pairs. So I'll just type it out again. So just so you guys understand the problem better. So there are 7 shirts, 5 jeans, all are distinct, 2 pair of shoes, and 3 caps. In how many ways can Rahul dress up before going to a party? So so whenever someone is dressing up, whenever a decent person is dressing up, we can assume that the person will need a shirt, a jean, shoes, a pair of shoes, and like, and since Rahul is going to the party, let's say he also wears a cap. Doesn't matter, but yeah, just for the sake of this question. So since there are so the number of ways of choosing the shirt is 7, since there are 7 shirts, and the number of ways of choosing a jean is 5. Similarly, number of ways of choosing a pair of shoes is 2. Since obviously you're going to a party, you want to wear the same pair, right? You don't want to wear one shoe of green color and one shoe of another color. So yeah. And let's say Rahul is also choosing one cap from the 3 caps. So the total number of ways in which he can dress up is he can choose one of those jeans. So 7C1, 7 choose one, into one, sorry, 7 shirts and one jean. So 5C1, then a pair of shoes. So it will be 2C1, and similarly a cap. So it will be 3C1, right? Which is just equals to like 7 into 5 into 2 into 3. So yeah, this will be the total number of ways. You guys can calculate its value later. This will be the total number of ways in which Rahul can just underline the answer. Okay, yeah. So someone is pointing out the answer in the chart, which is equals to 210. Correct. Because 5 into 10 is 10, 70, and into 3 is 210, right? So yeah, this was also a pretty straightforward question. So let's just see, let's just get another twist in here. Suppose Rahul has the option of not wearing a cap, because a lot of people don't wear a cap to the party. Suppose we have to count cases. Suppose Rahul also has an option to wear no cap. So in this case, how will we go about the problem? A straightforward way would be like, uh, we can just make cases, right? For case counting. Case 1, Rahul wears no cap. So in those ways of dressing up, he'll just need one shirt, which will contribute a factor of 7. Uh, one jean, so it contribute a factor of 5, and a pair of shoes, so it will be 7 into 5 into 2. So and case 2 would be like Rahul wears a cap. So while if Rahul is wearing a cap, then we had also already calculated the answer. 7 into 5 into 2 into 3, right? So by some rule, basically these two cases are the cases which we have made are disjoint from each other. Since cases are disjoint, so total answer here would be here is sum of case 1 comma case 2. Right? So it will be just like 7 into 5 into 2 into 3. I'm writing it a bit informally, but I guess you guys can understand as I'm explaining what I'm writing. That's right. So this will be the answer, net answer if Rahul also has an option to not wear a cap. Yes, this would be 70 plus 210, which would be 280. Another thing which I wanted to point out in here was it is nothing very fancy, but straightforward. Like for calculating this only, suppose Rahul has an option to wear no cap also. So here we divided this into two cases, right? But we can just straightforward calculate this as like how we can calculate this straightforward is that suppose basically we'll try to create a one-to-one correspondence. Suppose I call wearing no cap as also a type of cap, right? So do you guys get me what I'm trying to say? Like let's suppose there are three caps C1, C2, and C3. So if I introduce another cap, let's say C4, and I say that such that C4 means Rahul is wearing no hat. So this way, like this is just another representation. So in this way, I'll not have to make cases. So now instead of three ways of wearing a cap, I'll just have four ways. And whenever I'm wearing like the C4 cap, it will mean that I'm wearing actually no cap. Not me, Rahul, but let's say I'm Rahul. Yeah. So in this way, we can directly calculate the number of ways. So we'll just get 7 into 5 into 2 into 4 now. Earlier it was 3. And you can see that this is same as this factor is same as the factor which we discussed by the cases thing, like 7 into 5 into 2 and 7 into 5 into 2 into 3. The 7 times 5 times 2 comes common, and here we get a 4. So the same answer, just in a straightforward way without making cases. So this is also like not a very fancy trick or anything, but just something you guys can keep in mind. So to make the calculations faster, I would say. So yeah, basically, like we are just discussing the different approaches because we want to understand the principles of counting rather than like I'm just discussing these different ways so that you guys can understand the principles of counting. I'm not just here to solve some set of problems. I'm here to make you understand the concepts of counting. So yeah. So uh, so this case was clear. So now let's come to another case, the third question basically. So in how many ways can the word documentation be arranged so that all consonants come together? Okay. So first we'll since need the which are the consonants here and which are the vowels here. So since I have done a bit of my homework already, so I'll just type this out. What were the consonants and so basically here the vowels would be O, then U, then E, then A, then I, then O, right? Like it's not hard to calculate. It's not hard to see how are these the vowels and the remaining other consonants. So D, C, M, N, D, E, M. Right. So yeah, pretty straightforward counting. So the consonants and vowels we have just listed out because we want to see the number of ways in which the consonants come together. So basically the consonants will have to come together. So this means that these consonants will need to come in a group, will need to occur together. But these can be permuted amongst each other, but can be permuted amongst themselves. Like the just the new line. So what this means is that these consonants like DC, MN, TTN will need to occur together. But another valid ordering would be suppose TT and DCMN. basically these consonants need to be together, but their order can be anything amongst themselves. So that's what I'm trying to say here. And so basically this will be one group, but this group can be permuted amongst itself. And then there is no restriction on the vowels, that whether the vowels have to come together or not. So let's see first of all how many distinct vowels are there. So here there are two O's and one A, two O's, one A, one E, one I, one U. 1, 2, 3, 4, 5, 6, 3. Yes, so there are six vowels and like there are two O's, one A, one E, one I, and one U. So these vowels can occur amongst them. Like these vowels have no restrictions around them. So we can permute them in any ways. But one thing which we'll have to take care of is that there are two O's, right? So while permuting, we'll have to divide by a factor of 2 because otherwise there will be repetitions of permutations. So I'll just write the answer first for you guys. So basically there are like six vowels here. And so basically there are six groups and the seventh group will be the group of consonants. So it will contribute, let's say total number of ways will be. So these vowels and this group can be permuted in any way. So 7 factorial will be this because there are like six vowels and this one group. It's a total of 7. So it will be 7 factorial. But we'll have to divide this first of all by 2 factorial because there are two O's. Since we don't want repetitions, like basically one O before the other or other O before the first are the same cases, right? So we'll have to divide this by 2 factorial. And then we'll multiply a factor of like I'm not calculating the factor into number of ways of ordering consonants, right? Because we have just considered the consonants as a group, but they can also be like this group can be permuted amongst itself together. So this is the answer. So we'll need this value also, number of ways of ordering the consonants. So let's just calculate this also. The number of ways of ordering the consonants will be, first we'll count out the consonants here. Let's just say there is 1D, 1C, 1M, 2Ns, and 2Ts, right? So there are like 1, 2, 3, 5, and 7. 1, 2, 3, 4, 5, 6, 7. So there are like these, there are the we have just counted out the consonants. We have just counted out the vowels here. So now the consonants have to be ordered among themselves. So since there are like 7 consonants, so it will contribute a factor of 7 factorial. But we'll have to divide by a quantity, and that quantity is pretty straightforward, as we have already discussed. Since there are groupings of n's and t's, since these are grouping of 2n, so we'll have to divide a factor of 2 factorial because of the n's. And also we'll have to divide by a factor of 2 factorial more because of these 2 t's. So here the number of ways of counting will be like, so the number of ways of ordering the consonants will be this. The 7 factorial is just originally because there are 7 consonants, and since there are 2 repetitions of n and 2 repetitions of t's, so we'll divide by 2 factorial each. So so the total number of ways which we calculated was 7 factorial by 2 factorial. This part came from the total groupings possible, and this was because of the repetition of vowels, and into number of ways of ordering the consonants, which we have calculated here. We can just plug its value here. So this will be equal to 7 factorial by 2 factorial times 7 factorial by okay, 2 factorial into 2 factorial. Yeah. So this will be the answer. You guys can calculate it yourselves, but this will be the final value. Right. So I hope this is a clear. This was a bit more involved than the previous questions, but nothing special. This was also, I would say, a pretty straightforward question. So yeah. So let's come to the next question then. Maybe I just highlight so you guys can understand based the answer. Yeah. So now let's come to the fourth question. And the fourth question says that a question paper consists of 20 questions having two parts each. Each part consists of 10 questions. Students have to answer 12 questions in total, of which at least 4 questions should be from part 1 and 4 should be from part 2. In how many ways can the student select questions? So basically, let's just write out all the information given in the question in better manner. So basically, total questions is 20. Uh, need to attempt 12. 4 from part 1, 4 from part 2, at least 4. So this will be greater than equals to 4 and greater than equals to 4, right? And there are 20 questions and each part consists of 10 questions. So another piece of information is 20 questions. P1 has 10 questions and P2 has 10 questions. So yeah, this is the information total overall which is given to us. So I'll just like sometimes writing out extracting the information from the problem statement itself is also needed. It's pretty straightforward, but I just like to type out all the relevant information and just leave out the English. So yeah. So now we have to find the number of ways in which I can select the questions to answer, right? So here we have to answer 12 questions in total. So here we'll use some case analysis. So we have to answer 12 questions, right? And at least 4 questions from each part should be there. So how can I break these 12 questions into part 1 and part 2? It's straightforward. There can be a case where I answer 4 questions from part 1 and 8 questions from part 2, or 5 from part 1 and 7 from part 2 and 6 from part 1. Put these in parentheses so you don't get confused about the cases. 6 from part 1, 6 from part 2. Similarly, like I'm just typing these out so you guys, like we can like calculate all these things separately without doing hand wavy stuff. So yeah, 10 from part 2, or there can be, I can answer 8 from part 1 and 4 from part 2. And 9 from part 1 and 3 from part 2 is not possible. This is straightforward because like we have to answer at least 4 questions from part 2 also. Similarly, we had to answer 4 questions from part 1, so we started from 4 at part 1 and we don't include other cases. So we'll just have to count these like this 1, 2, 3, 4, 5. So we'll just count the number of ways for these 5 cases and we'll sum all of these 5 cases and we'll get our answer. So just to delve into it a little bit more. So basically the case 1, I'll just refer to this as case 1, the 4 part 1 and case 1. This will be case 2, case 3, case 4 and case 5. So in case 1, basically I have to answer 4 questions from part 1 and 8 from part 2. So 4 from part 1 will require, there are 10 questions total in part 1, similarly in part 2. So I'll choose 4 questions out of these 10 to answer. from part 1, and similarly I choose 8 questions to answer from part 2. So this will be 10c4 times 10c8. Similarly, let me just copy paste this. So this will be case 2. In case 2, I have to answer 5 from here and 7 from here. And in case 3, I'll answer 6 from each. So if you guys have any doubt, you guys can write it in the chat and I can try to answer your doubts. Will be just like we are like this is a bit robotic. It's going a bit robotic, but we'll have to do this anyways if we are calculating the answer. Sometimes like you can't avoid this type of stuff in counting. So these are the 5 cases which we listed, and in these ways only I can answer them, basically selecting 8 from part 1 and 4 from part 2 and up to all of these cases. So my total answer will be, since all of these cases are disjoint, since I am answering different number of questions from each part in each case, total answer will be equal to sum of all cases. So you guys can do the calculations later. They are not really relevant, but yeah. So 10c4 times 10c8 plus 10c5 times 10c7 plus this plus this plus this. So this will be the answer. I'll not calculate it, but yeah. So was also like sometimes you need to make some cases and apply the sum rule. Some rule seems obvious in counting, but yeah, sometimes case analysis is required. There is no way or no smart way of escaping this sort of stuff sometimes. So let's come to the next question. This is a very straightforward formula-based question. So the question is, what is the coefficient of sixth term in the expression 5x to the power 4 minus x cubed by 2? So basically, I just wanted to tell you the formula again, remind you guys about the formula that uh, TR, basically the RA term is equals to n choose R minus 1 times A to the power n minus R plus 1 times B to the power R minus 1. So we all know hopefully the binomial theorem, and the RA term comes out to be this. Nothing fancy. Just one thing to note here is the notation. Basically, what does it mean by the sixth term? Because we have just in an arbitrary manner we have just told that the sixth term will mean this term, like the a to the power, and R term will mean a to the power n minus r plus 1 and b to the power r minus 1. Similarly, I could have defined in some other way that R term means like b to the power n minus r plus 1 and a to the power r minus 1. So sometimes we just have to take care of these notations which have been introduced. And uh, after being familiar with these notations, this question is pretty straightforward. So yeah, so here A is, so I'm not going to calculate the whole question, but A here is basically 5 by 13 times x to the power 4. And similarly, B here is minus 1 by 2 times x cube, and yeah, n is just 7, and R is 6 because we need to find the sixth term. So just plugging in these values in this formula will give us the answer. So nothing fancy here going on, just straightforward binomial theorem or just straightforward counting arguments. But the main thing to keep in mind is that what is the definition of the R term? which is something not necessarily which helps your understanding, but something which is a notation which has been like adopted universally. So we should know about this notation. Like R at terms is a b raised to the power r minus 1, not a raised to the power r minus 1, if you guys understand what I'm saying. So yeah, this question was straightforward, nothing fancy. And now coming to another straightforward question, which has been, I think, discussed in the lectures already. Just wanted to remind you guys about the Catalan numbers. So yeah. By the way, if you guys have done this course in previous years discrete maths also, so you guys might find this assignment the same, these questions as the same as the ones which were discussed in last year's assignment. But okay, so someone is asking a question. For question 5, is there any other way to solve? Okay, so for question 5, what is the coefficient of the sixth term in the expression this? So, like I said, is there any other way to solve? Any other way would still require counting, and I would say this is not a question which is based on counting, rather, it's much more of a question which is based on convention. Like the sixth term, the Rth term is defined as this only. Okay. So, guys, can you hear me? Hello? Can someone let me know in chat if they can hear me? Okay, cool. You guys can hear. Sorry for the internet issues. I hope the Wi-Fi now remains constant. My, I'll just share my screen again. So yeah, so my screen is visible. Uh, is my screen visible? Can someone let me know in chat? Okay, nice. It is visible. So let's get going in this sixth question. So the sixth question which I was discussing before this in fifth question, I was just saying that this is more of a formula based question or like convention based question. So there's no any other way of counting, right? It's just something which you need to know that this is the convention which has been universally adopted, that the TRA term will be defined as the one which has a to the power n minus r plus 1 and PR minus 1 powers. Okay. So let's come to the sixth question now, guys. So sixth question also was a very straightforward question, just Catalan numbers, which has been discussed in the lectures, I believe. So which of the following is not an application of Catalan numbers? So counting the number of ways in which a polygon can be cut into triangles by connecting vertices. This is an application of Catalan numbers. Similarly, okay, the V part is counting the number of ways in which a person can choose a red ball from a bag containing 10 black, 5 red, and 15 blue balls. So this will just be like we need to choose a red ball from this much boxes. So in how many ways can we pick a red ball? So there are only 5 ways. Since there are only 5 red balls, there are only 5 ways. Here the answer would be equals to 5. So there was no need for Catalan numbers here. Just straightforward, we'll get the answer 5. So here the answer I would say is B, as the answer is 5 only. So this is like you can see, this is not an application. Oh, this is basically application of nothing, just straightforward counting. Like how many red balls can we get? Just 5 red balls. The C part is if n people are seated around a table, how many ways can they shake their hands? So this must have also been discussed in the lectures that this also corresponds to Catalan numbers. Similarly, expressions containing n pairs of parentheses is also an application of Catalan numbers. So yeah, I guess the answer is B, as the answer is 5. Like, okay. So if you guys have attended this course last time also, this NPTEL Discrete Maths course, then you guys would be familiar with these questions as I am discussing the previous year's assignment only. But still, for the people who are new, these are more of practice questions, right? So it's better to discuss these questions, right? So let's just get to the seventh question. So seventh question says that there are two vacant positions for the president and vice president of a club. The post can be given to any of the 50 members of the club, and a member can take more than one cabinet position. So this line is important. A member can take more than one cabinet position. So in how many ways can the two vacant positions be filled? So basically what the question is saying is that there can be a person who is president as well as the vice president. So I would say this is more of a straightforward counting based question. So how can we calculate for the post of president? How many choices do we have? Since there are 50 people, we have 50 choices for the post of president. And similarly, for the post of vice president, if the president has been appointed, that person can also be appointed as the vice president, since a member can take more than one cabinet position. So even if someone is a president, he can also be a vice president. He or she can also be a vice president. So the number of ways of choosing a vice president is also 50, since repetition is allowed. So 50 into 50. So the answer is 2500 here. Like I would say it's pretty straightforward, as we just count how many ways can we select the president. There are 50 ways. Similarly, for vice president, there are 50 ways. 50 into 50 is 2500. So now let's again, like previous times, let's just introduce a different version of this problem where a member can take only one cabinet position. Can take only one cabinet position. So here, what will happen is there are 50 ways of selecting the president. And as soon as the president is selected, he or she becomes unavailable for the post of vice president. So there are 49 more ways to select the vice president. So the answer here would be 2450, I believe. So one thing to note here, do you guys think sometimes we divide by two? Suppose like if we had to select two people out of a group of 50, we then in that case we choose 50 into 49 and then we divide by 2 also. Suppose the question was just that uh, the question was only asking that select two people out of 50. Here we just do 50 C2, which is 50 times 49 and divided by 2. But here when we are selecting a president and a vice president, we are not dividing by 2. So like this is like not something which is very like fancy or something very strange. This is just a pretty straightforward argument because here we are selecting two people and these people are like not ordered in any way. Like we just need to select a group of people. What we are doing here is that we are taking a group of two people and then appointing one as the president and one as the vice president. So if you guys want to count it in this manner, like here, this argument is correct that we can take only one cabinet since like we can select the president in 50 ways and the vice president then can be selected in 49 ways. We don't divide by two because if A is president and B is vice president, and the second case B is president and A is vice president, these two cases are distinct cases. So I hope you guys understand what I'm trying to say. I have not written it down because it can be understood easily. So these two cases here are different if A is president and B is vice president, or A is vice president and B is president. So that's why here we don't divide by two. But here, suppose we only need to select two people. So in that case, selecting A and B or selecting B and A are the same scenarios. So here we divide by two. So if we just want to count this, a member can take only 50 cabinet positions instead of counting it as 50 into 49. What we can also say is that, uh, like first, a very straightforward argument. This is also straightforward. First, select a group of two people. Then appoint one of them as the president from that group. Appoint one of them as president and other as vice president. Right. This is also a valid way of counting this, of making a cabinet of one president and a vice president. If we only have one cabinet, like one member can take only one president, one position, one cabinet position. So this can be directly calculated by taking a president and then taking a vice president, or this can also be thought of as first selecting a group of two people, and then from that group of two people, we appoint one of them as president and other as VP. So this way, how we'll count is that we'll first choose in 52 ways the group of two people, and then making one of them as president and other as VP will be two ways. Because if A and B are selected, A is VP and B is president, and A is president and B is VP are two different ways. So here also in by this way of counting also we'll get 15 to 49. So both ways we get this answer 15 to 49 by both ways of counting. So I just wanted to point out that there is no fixed way of counting for stuff. The more number of ways you find for counting the same stuff, the more your understanding increases, like what's happening and why this sort of stuff and all that. So yeah, this was the seventh question. So let's come to the eighth question now. So in eighth question, the question is a bag contains 5 black balls. So let's just put that information down. 7 white balls and 9 red balls. The number of ways in which 3 balls can be drawn from the bag so that all the 3 balls will have different colors. So we need to draw 3 balls of different colors, right? So I would say this is also a very straightforward question. So 3 balls which should all be different colors. So it means we'll need one black, one white, and one red ball. So this just means that we'll need to choose one black ball out of the 5 black. So it will contribute 5C1 or just 5. I'll write it down as 5C1 into, we'll need one white ball. So it will be like choosing one ball out of 7 white balls. And similarly for red ball, we'll have 9C1. So this will be the answer, basically 5 into 7 into 9. So this is also, I would say, a straightforward counting question. The question can be made a little bit more tricky, but still not too tricky. Is that suppose so that find the number of ways in which 3 balls can be drawn two balls so that 2 balls at least have different colors. Suppose in which 3 balls so that two of the 3 drawn balls will have different colors. So this was the question. Uh, I'll so here the question here the in this question in the question which I gave in the previous question the answer was pretty straightforward because there was only one case of drawing 3 balls of different colors, right? One should be black, one should be white, and one should be red, since there are 3 colors only. But now what I'm saying is that I need to suppose take out 3 balls so that at least two of the 3 balls will have different colors. So two of the 3 balls should have different colors means this case is also acceptable that two black and one red is drawn. So basically we'll need basically that all the balls should not be of same color. All the 3 balls should not be of same color. So this case is acceptable. So this just implies that this is equivalent to not picking all balls of same color. And the NPTEL doubt discussion group you can find, Anup, you can find on your Swayam portal. After logging into Swayam portal, there will be an option of like ask a question or something. When you click on that, you will be able to go to the discussion forum. So yeah, I think logistics question you can search on the internet to find the doubts to logistics related questions also. So that's fine. But let's just focus on this problem for now. So now that as I was discussing, I changed the problem a little bit. So earlier we needed to draw 3 different balls. And now what I'm saying is that at least two of the 3 balls should be distinct. So this problem is equivalent to not picking all balls of the same color. Because if I pick all balls of same color, this case is not satisfied. And if one of the balls will have different color from the others, then there will be at least two of the 3 balls will have different colors. So how can this be calculated? This is also very straightforward. So this is just total number of ways of picking 3 balls minus number of ways of picking 3 balls of same color. Right. So this is how we will calculate. The total number of ways of picking 3 balls is, I guess, pretty straightforward. Like you guys can see that there are a total number of 5 black, 7 white, and 9 red balls. So how can we pick 3 balls? Like any 3 balls we have to pick. So we'll just pick like any of these, like 12, and we'll just pick 3 of these 21 balls or something like that. So I'm not going to calculate these values here, but I just want to point out, you guys can calculate these values by yourself. But I just want to point out that if we twist the question a little bit, its formulation way of like counting can change. Here we could here we could count in a straightforward manner. Here we will have to count in a bit different manner, right? You guys can calculate it later yourselves, and this is not a hard problem. So okay. So let's come to the 10th question now. And I would recommend you guys to solve these sort of problems because this will help you in identifying different sort of counting arguments involved. So yeah. Busy counting is like this only, like you just tweak the problem a little bit and the method of counting can change and you can find some more efficient version of counting or something like that. So yeah. Let's go to the ninth question. So ninth question is, what is the total number of paths from -3, -2 to -2, 5, 6 without crossing the line passing through -3, -2 and 5, 6? That is without crossing the diagonal. So basically, it's a straightforward application of Catalan numbers. So you can see that what we have to go from, like, in the x coordinate we have to go from -3 to 5. So basically, in x-axis, since we have to go from -3 to 5, we need to cover a distance of 8 units. Similarly, this 8 units comes from like 5 minus of -3. This is straightforward application. So because we have to start from -3 and we have to go to 5, so we need to cover 8 units. Similarly for y-axis, we need to cover a distance of, it will be 6 minus of, we need to go from -2 to 6, right? So it will be 6 minus 2, which is again 8 units. So in x and y, both the axes, we need to cover a distance of 8 units. So you can think of these corner points as being top right and bottom left corners of a square grid. Like -3, -2 is the bottom left point of a square grid of 8 cross 8, and 5, 6 is the top right of the 8 cross 8 square grid. So basically what we are saying is that we in our 8 crosses. So the problem basically reduces to finding the number of paths from bottom left to top right point in a 8 cross 8 square grid. And this is just straightforward application of Catalan number. So this will be like, hello. Sorry guys, again a bit of network broke down, but yeah, I hope you guys can hear me now. So this will be just like what I was saying was that the problem reduces to finding the number of paths from bottom left to top right in an 8 cross 8 square grid. So this will be just a straightforward application of Catalan numbers. Basically, we need to count the 8th Catalan number, and can all of you guys must already know the formula from the lecture. This is equals to like 2nCn minus 2nCn plus 1. So this will be 16C8 minus 16C9. So yeah, this calculation can be done later. It comes out to be, I guess, 4862. So a straightforward application of Catalan numbers, nothing fancy going on here. Just like you just want to point out here that you can shift the origin also in the Catalan numbers, right? You don't need to go from exactly 0, 0 to 9 comma 9 or 8 comma 8. Basically, if the origin is shifted to -3 comma -2, still if the other corner point lies on a like like on the line, like basically if the other point also lies on like the square grids. Basically what I'm saying is that, sorry for the confusion. What I'm saying is that the square needs bottom left point need not be 0 comma 0. It can also be -3 comma -2 or any other offset to the origin. And still you guys can apply the Catalan number. So yeah, straightforward, I would say. So ninth question is also done. So let's come to the 10th question now. Yeah. So 10th question is, oh nice. Aditya has already calculated its value. So 10th question is basically a very calculation based question. I won't be doing the calculation. Just it was just here to help you guys help you in your calculations and know like what are the actual values for these 20C4. The basically how do you calculate this 20C4? So 20C4 is equals to like basically any NCR in general. Just to remind you about what NCR means. NCR is equals to n factorial divided by n minus r factorial times r factorial. This is the formula for NCR, and similarly for NPR, which is basically permutation, the formula would be n factorial divided by n minus r factorial. So nothing fancy. You don't even need to remember these formulas, but yeah, just straightforward. If the notation comes like what is 20C4, so you guys can just plug in the value of n and r and calculate this. Similarly, calculate this. Also, you don't need to exactly calculate like NC are as it is first, like you don't need to first calculate 20C4 and 21P2 and 100C99 and then divide overall. You can just write it in terms of factors like 20C4. You can just write it in terms of factors of these, and similarly for 21P2, and some factors will be cancelled or something like that. So yeah, I'll leave this question. Just I'll just say apply the formulas and calculate. Straightforward. This is NPR is also like these are not exactly formulas. Also, these can also be thought of about easily because NPR is just basically a number of permutations possible of our objects when we are choosing them from an objects. And similarly for NCR, we are choosing a group of R from n objects. So yeah. Okay, so Surya, week 1 and week 2, this week's the assignments solutions will be available, I guess, after you have submitted the assignments. I guess the deadline for week 1 and week 2 assignments is tomorrow, right? So since I'm not sure totally, but I believe they'll be available after tomorrow, or maybe like after some time after tomorrow only. Like basically you won't get the solutions before the deadline. That's what I'm saying. Okay. So yeah. So now let's go to some problem based on the week 2 lectures. So week 2 lectures were based on set theory and stuff. So that was also pretty straightforward, I would say. But you guys should know about sets because you require sets in a lot of different settings in computer science or in maths also. Knowing more about sets is never a bad thing. So the first question. So question is, if A and B are sets and A union B is equals to A intersection B, which of the following statements is true? basically either one of A or B is an empty set, B is a proper subset of A equals B, or A is a proper subset of B. So we guys already know there is a Venn diagram representation of sets, right? Which helps us in our understanding of sets much better. So in Venn diagrams, like you can like sort of get a feel that if A union B is equals to A intersection B, this means the overlapping area is equals to the total area of intersection of these sets. So this can only happen when A equals B, right? So you can get sort of an intuition or a feel of that answer would be A equals B, right? But generally in mathematics, like in any proper science, you don't work on intuition only. You need to give a proper proof also. Why would this actually be true? So yeah, by intuition, we can see that A union B is, if A union B is the intersection B, then A is equals to B. But why is this true? So we can try to prove this. I believe this sort of proof is also done in 12th class mathematics, but of sets. So let's just see how this proof would look like. So basically, if we want to show, basically from intuition, we see that A equals to B, but why will this be? So if we show that A is a subset of B, we know this property that A is a subset of B and B is a subset of A. This plus equals to B, and this is an if and only if double integration. Note that I've not defined here proper subset because it won't be a proper subset. So if we show that A is a subset of B and B is a subset of A, then we'll get that A equals to B. So basically, we need to show that A is a subset of B and B is a subset of A. To show A equals to B, so we just show that A is a subset of B. From this, similar for B is a subset of A also, so I'll not discuss that again. But so how can we show A is a subset of B? So what does a set A being a subset of B mean? It means that any element small a in A is also a member of B. Right? We need to show something like this. Right, guys. So basically, how can we say is that? How can we say this? Basically, we need to show this. We need to show that. Only then can we say that A is a subset of B. So one natural approach would be see this element A in A. Okay. This implies that this element A will also be in the set A union B, because this is how union is defined. Basically, union contains the elements of both the sets, right? Since small a was in capital A, so small a will also be in capital A union capital B. And this will imply that since A union B is equals to A intersection B as given in the question, so this will imply that A is in A intersection B, right? So, and by the definition of intersection, if small a is in A intersection B, then it is in A as well as in B. So by definition of intersection, we get that A is in B also. So so we started from here that let us take any element small a from A, and then we showed that this small a will also be in B. So this will imply that any element capital A is a any element small a in capital A is also a member of capital B. This was a very straightforward one-line proof. So from this we can say that A subset of B. And similarly, in the other direction, we also need to show that B is a subset, capital B is a subset of A. So in that case, we'll start with a small element, an element small b in capital B. And we'll just like substitute instead of A, we'll write B, and instead of B, we'll write A. And similar proof will give us that B is a subset of A. So if A is a subset of B and B is a subset of A, then this means that A is equals to B. So this is how the equality of sets is defined. So hence proved. So note that one thing to note here is that we started out with a bit of intuition that in Venn diagrams, if the overlapping area is equals to the total sum of the areas of A and B, then A and B must be equal. Right. So in general, whenever in further problems or in higher level courses also, what will come across is that a lot of times you will get the intuition of why this, what something will be, whether something will be true or something will be false. But generally, like mathematics or like proper science involves like proving that intuition also, right? You guys should not only develop intuition, but you guys should also develop the skills on how to prove that intuition. And this sort of thing becomes really necessary when you go into some advanced applications of stuff, because a lot of times intuition can also fail you. So that's why you should always try to uh, develop a habit of proving your intuition also. A lot of people don't like doing writing down the proofs as they think it's obvious, but trust me, it's not obvious a lot of times. And what's obvious to you may not be obvious to someone else. So, so keep in mind that generally knowing how to write the proofs is also a very important skill if you want to do some advanced courses and stuff like, because there you can't say everything based on intuition. Yeah. Okay. Enough philosophizing. Now time for next question. So yeah. So the second question is also basically this all this question set is not really that interesting because it involves just application of sets and definition of sets. But I would still be discussing this. So the A is given as 3, 3, 4, 5, something like this, and B is given as another set. So note that B is a set of sets. So, uh, basically, B is a set which contains a set 5, 9, and a number 12, and another set, and another set. C is an empty set. 5 denotes an empty set. So, and actually, is not an empty set. C contains an empty set. Basically, what I mean to say is that y one second. Y denotes empty set, which is equals to this. So the value of C is equals to pi. C is given as pi, which denotes a set which contains empty set. So actually C is not an empty set. C contains an empty set. So if we'll say that size of C will actually be 1 and not 0. Okay, just want to point this out because a lot of people get confused, like what is an empty set and why is C not an empty set. C is a set which contains an empty set. So a set can be a collection of sets also, as you may have seen in power sets or something like that. So here C contains an empty set. So C contains one element, which is an empty set. So the actual number of elements in C is 1, right? So basically cardinality of C is 1. And similarly, X is given and Y is given. So which statement is true? So let's say cardinality of A is 7. So it is true that A contains 7 elements here as it is given, but actually a set is a collection of distinct elements. Distinct elements. If you're going by proper definition of sets, there's something called multi-sets also, but let's just ignore them for now and just say that let's just stick by the basic definition that a set is a collection of distinct elements. Distinct, I'll make it in bold because it is important. So this implies that essentially the elements contributing to A are 3, 4, 5, 6, and 9. Because 3 is occurring twice or 6 is occurring twice, it will not contribute to the cardinality of that set. So this implies cardinality of A will actually be these distinct elements, which are 5 elements. And even though A contains 7 elements, but cardinality counts only distinct occurrences of elements. So there will cardinality of A will be 5 only. So let's come to cardinality of B. So B is a set which again contains an element 12 and some sets. So one set contained in B will be one element. So let's just go about with cardinality. Let's start with cardinality of B. So B will contain null element 5, 9, and one element 12. And this set, like 1 comma set of x comma y, this whole is a set, right? So this will also be actually counted as one. And similarly, ABC is also a set. So B actually contains only 4 elements. Why? Because B is a collection of sets and some numbers. These sets in itself can have more cardinality, like 5, 9. A set of 5, 9 will have a cardinality of 2. But since this set is represented as single element in B, so it will contribute to B as only one, since it is a single element in the set B. In itself, it can be a very large set. So let's say like there is, like for example, let's just say, I'm just giving out an example. The cardinality of B will be 4 only. So for better understanding, let's take set X equals like 1, 2, 3 up to n. So this implies that cardinality of X will be n. But suppose I take a set Y, take another set Y, which is a set which just contains the set X. So basically Y is actually, even though Y is actually a set which contains the set X, just putting the value of X here, 1, 2 up to n. This doesn't mean that cardinality of Y is also n. The cardinality of Y is cardinality of Y is 1 only, because Y essentially contains only one element X. Even though that X in itself can have a cardinality of n, but Y contains only that element. So this is something which you guys should keep in mind, that a set of sets, the set inside will be counted as one object only. So like this is something like this I discussed because it's interesting is that the set Y which contains the set X, the cardinality of the inside set, the set X is greater. It is n, but the outside set has cardinality of 1 only, even though the set X is contained inside Y. So just wanted to point it out that even if X is contained in Y, cardinality of X can be greater than cardinality of Y. So yeah. So enough for this. So let's just take cardinality of C. Here cardinality of C, as I already discussed, will be 1. Since C actually is a set of sets and the set contained in C is an empty set. So cardinality of C is 1. Similarly, cardinality of x is 3 because it contains x, y, and z. Cardinality. So I'll just denote cardinality by like the symbol similar to absolute value. So cardinality of x is 3. And similarly, cardinality of y is okay. So these cases are last three cases are pretty straightforward. But yeah, this A and B, the cases A and B need you to know require you to know the definition of sets. So from this, which of the following statement is true? We just calculated every set's cardinality. So the option B, which is cardinality of B is 4 is true. So option B is correct. Someone has a question in the chat. Yeah. So yeah, Rohit, the answer is B. So yeah, correct. So this question was more based on the definition of sets, and you guys should know the distinction. Okay, so let's move on to the next question now. Okay. So the next question is, let's set A is 3, 5, 6, 7, 8, 9, B is this, and C is something. These are C set. Which of the following is not a disjoint set? Okay, so these are the four sort of options which are given. So let's just see what are these sets one by one. So disjoint sets are the sets, first of all, first of all, let's just uh, remember the definition again, recall the definition again for disjoint set. Disjoint sets are sets which don't have any common element, right? So basically this implies A and B are this any two sets X and Y, let's say A and B, you will get confused with the questions in B. X and Y are disjoint sets if and only if I double F denotes if and only if X intersection Y is an empty set. Basically, if if and only if X intersection Y is an empty set, that is, they don't have any common intersection, only then are they disjoint sets. If this is not phi, then they are not disjoint. So let's just see set A and set C. So set A has elements 3, 5, 6, 7, 8, 9, and C has -1, 0, and 1. So A and C's intersection is since they don't have any common elements, their intersection is phi. So A and C are disjoint sets. B and C in B contains the elements 2, 4, 5, 11, 14. So again, no common element with C. So B and C are also disjoint. Let's just go to option D first. And A and B. A contains the elements 3, 5, 6, 7, 8, 9. And B contains 2, 4, 5, 11, and 14. So A and B at least have a common element of 5, right? So A intersection B is equals to, this will also be a set. They have a common element of 5. Is there any other common element? No, I don't think there's any other common element. Right. Yeah. So the manual way of checking whether there's a common element or not is just checking element by element. Suppose take element 3 of A, like first element 3 of A, and check if it's in B. Similarly, take 5 and check if it's in B. Take 6, check if it's in B, and similarly for all element. So manually you can do this pretty fast, I guess. So in this A intersection B, we'll get as 5. So this is not equals to, which is not 5. So A and B are not disjoint. And the question was asking us which of the following are not disjoint. So the answer is D. Yeah. System. So just to cover the C option also, I did not cover the C option. Let's just check for C option also if it's disjoint or not. So C option checks. Yeah, Deepak, you're correct. The answer is D. But just let's just check C option also. So C option says C and A intersection B. So one set is C and the other is A intersection B. First, we'll need to calculate what is A intersection B. So A intersection B is, we need to find out A intersection B. What is this? Which we have already found out in option D. So A intersection B is just 5. And set C contains only -1, 0, and 1. So this implies, like, since the set 5 and the set -1, 0, 1 has no common elements, so this is also disjoint. Oh, okay. Maybe I made a mistake while reading the question. The C option is A union B. C and A union B. So we'll have to calculate the union of A and B first. So we're just calculating the union of A and B. Like, I'm doing this, all of this stuff might be boring. You might find it very manual labor, but I'm just doing this because sometimes we just need to write stuff out to know the what things are working. Yeah. Deepak, C is A union B. I have corrected myself and writing out the value of A union B. So A union B will be 2, 3, 4, 5, 6, 7, 8, 9, 11, 14. You guys can see, I think this will be the answer for A union B. A union B can easily be calculated. Take all elements of A, take all elements of B, put them together, and repeating elements should be taken as unique elements now in the union B, right? So this will be the A union B. And since C contains only -1, 0, and 1, so this set does not contain any of these numbers. So their intersection is 5. C and A union B's intersection would be 5. So they are disjoint. So C option is also not correct. So answer was D, and only D, like not multiple options are correct. So yeah. So now let's come to the question. The question says that okay. Yeah, so you guys are answering faster in the chat, but I'll still uh, try to solve this question properly so that other people can also understand what's happening in this question. So let's set A is equals to 4, 5, 6, 7, 9, and P denote the power set of A. What is the cardinality of P of A? So before that, power set of A is power set of A. You guys must all know. It is basically the set of all possible subsets. Power set of A means set of all possible subsets of A. In this, like the null set and the A itself is also, the set A is also included. So yeah, so set of all possible subsets of A. And how is its cardinality calculated? The cardinality of power set of A is, suppose A has n elements. Suppose A has n distinct elements. Since we are uh, calling A a set, so A will assume that A has distinct elements because the set has distinct elements. So then the cardinality of power set of A would be 2 to the power n. And how can you calculate this? It's pretty straightforward. So while counting the number of possible subsets of A, you can just take every element of A and you can make two guesses whether it will be included in the subset or it will not be included in the subset. So there are two cases for every element. So there are n elements. So the answer will be 2 to the power n. So the size of power set is 2 to the power n. So straightforward application of this formula. So this implies that cardinality of PA. Here we are given that A is 4, 5, 6, 7, 9. So we can just take that cardinality of A is 5. So this implies that cardinality of PA is 2 to the power 5. And this will be equals to 32. So this implies cardinality of P of A. So basically power set of power set. This will be a complex data structure. This will be a complex set, but we can just straightforward apply the formula which we discussed. So the power set of A has cardinality of 32. So the power set of A will have a cardinality of 2 raised to the power 32. So this will be the answer. So a straightforward, again, a straightforward application of the formula, I would say. But yeah, nonetheless, you guys should be able to answer this. So this has been discussed. So now let's go to the next question. Any doubts so far? Is there a message in the chat? Okay, so someone is answering to the part 32. Yeah, it is correct. Okay. So now let's come to the fifth question. So fifth question is let A is X such that X belongs to Z. Z basically means Z is the set of integers. So yeah, so this implies basically this is a representation of set A. So set A denotes all the integers which lie between -2 and 5, and at both endpoints equality is there. So just writing out the set A, it will be 4 and 5. Yeah. So Z is the set of integers, and the set of A will be basically this. This is the representation of A given in the question is a compact representation, but the value will be the value of A will be this. Set A will be this, and B is basically the set of prime numbers. B is set of prime numbers, right? But since there are infinite primes, so B is sort of an infinite set, right? And A is a finite set. So now we need to calculate A minus B. Basically, subtraction in sets, you guys must have studied in the lecture how subtraction of sets is done. So to calculate A minus B, basically we are subtracting an infinite set from a finite set. But thankfully, this is quite easy because we just need to check whether the element of A is present in B or not. So like we don't have to iterate over in anything over the infinite. We just have to iterate over the finite A, each element of A, and check whether it's in B or not. If it's in B, then it won't be A minus B, else it will be. So just constructing A minus B step by step. So minus 2 is in A, but it is not in B since B set of prime numbers. So minus 2 will be in A, similarly minus 1, similarly 0. Similarly 1 is also not a prime number. So but 2 is a prime. So set A contains 2, but B also contains 2. So 2 won't be there in A minus B. 3 is also a prime, so 3 also won't be there. 4 will be there because 4 is a prime. 4 is not a prime, so it will not be in B, but it will be in A. Similarly, 5 won't be there because 5 is a prime. So A minus B is -2, -1, 0, 1, 4, which is option C. Right. And many people have written this answer C, 2, 3, 5 need to be removed. Yes, your answer are correct. So this was the fifth question. So basically it was a pretty straightforward question, but still the main aim of this question was so that you guys understand how to calculate this A minus B. Suppose A and B both were infinite sets. Okay, let's say I told you that, let's just introduce the twist in the question. That is the set of all natural numbers. Okay. And B is the set of prime numbers. So then what will be A minus B? Basically now we need to find a compact representation for, like, we are subtracting from an infinite set another infinite set. So what will be A minus B? Will anyone write in the chat? Okay, this will be straightforward, like from the set of all natural numbers, we are removing all the prime numbers. So it will be set of composite numbers, because numbers which are not prime are composite. Will it just be set of composite numbers, something more along with this? Is Are you guys able to understand what I'm asking? Is this statement correct? What I have written? A is the set of all prime natural. A is the set of all natural numbers. B is the set of prime numbers, and A minus B set of composite numbers. Okay, Aditya. No, negative numbers will not be included. We are writing negative numbers should also be included, but I'm saying A is a set of all natural numbers. Natural numbers are by default positive. They are not negative. Yeah, numbers other than prime numbers, which are called composite numbers. Okay, guys, a lot of you guys uh, are being confused with this A and the A as in the question. I am I'm asking a different question. This is not the same question as the one. So suppose change the notation. So I have just said X is the set of all natural numbers, Y is the set of all prime numbers, then X minus Y set of composite numbers. Just tell, is it true or false? Okay, so so it was a bit tricky question, but a lot of guys are saying that it's true. A lot of people are saying it's true, but it is false. Why is it false? You need to include something else. Can someone guess? No, 0 is not a natural number, Ravir. So it will not be included in A anyways. Basically, okay, I'll just answer this for you guys. It's nothing very fancy, just trivial. So this is false. The correct claim would be XY set of composite numbers union with 1. Uh, why am I saying this? This is because 1 is neither a prime nor a composite number. We have learned this in high school, right? So except 1, every natural number greater than 1. Every natural number greater than 1 is either prime or composite, right? So for all those numbers, the X minus Y will be set of composite numbers. But since 1 is neither prime nor composite, but it is included in the set of natural numbers. So we'll need to write set of composite numbers union 1 separately. A bit tricky question, nothing fancy. Yeah, Aditya Kumar, you are correct. And 1. This was what I was asking this question. That the set of composite numbers in itself is not complete the answer. We need to include 1 also. So yeah. So let's come to the next question. Next question basically is asking In a group of 120 people, 50 people love to eat dairy milk, 70 people love to eat Kit Kat, and 20 people do not like any type of chocolate. Wow. There are people who do not like any chocolate. So how many people love to eat both types of chocolate? So basically this is also a set question. We can just define a set A, which set A, we can define set A as set of people, who love dairy milk. We can define set B as set of people who love Kit Kat. So basically what we are given in the question is the cardinality of A is there are 50 people who love dairy milk chocolate, and there are cardinality of B is 70 people who love to eat Kit Kat. And let's say we define another set, the universe set, basically the set U as set of all people. Set of all people. Basically, this set you will include all the people who like dairy milk, who don't like dairy milk, who like Kit Kat, who don't like Kit Kat, and all sorts of people. So this is basically called the universe set, right? So you set of all people, a set of people who love dairy milk, who love Kit Kat. So we are given that cardinality of A is 50, cardinality of A is 70, and total group of people is given 120. So cardinality of U, the set of all people, is 120. And we are also given that 20 people do not like any chocolate. So how can this be represented in set form? The people who do not like any type of chocolate, basically they don't like dairy milk as well as they don't like Kit Kat. So the people who don't like dairy milk can be represented with A complement, and the set of people who don't like Kit Kat can be represented with B complement. And we need to find the set of people who do not like both of these. So there will be an intersection here. So this A complement intersection B complement denotes the people who do not like any of the chocolates. Not one of the chocolates, but they don't like both of these chocolates. So this is given as 20. Right. So this is the information basically what was given to us. We have written all this information in set form. And now we need to find how many people love to eat both type of chocolate. So it will be given by who love dairy milk as well as intersection with who love Kit Kat. So we need to find this. We are given A, B, and universe set, and we are also given A complement intersection B complement. And now we need to find the value of A intersection B. So by Venn diagram, it becomes a lot more easier to see how this can be done. But straightforward, like applying set formulas and stuff, also you can find this pretty easily. Basically, uh, what we can say is that so here we just need to find the cardinality of A intersection B. Okay, so we know that A complement intersection B complement is 20. And we also know that by set formulas, I can't draw the Venn diagram because I don't have tablets, but I'll just write this in set notation. The number of elements in A union B plus the number of elements in A complement intersection B complement is equal to the cardinality of the universe. Is it clear to everyone? Why is this the case? It's pretty straightforward because like basically A union B, and you can see in the Venn diagram how this will be true. But even without a Venn diagram, you can see that A union B and A complement intersection B complement. These are basically complements, or these sets are complements of each other by De Morgan's law. If you have studied De Morgan's law, then you can see straightforward. So basically a set X and its complement together have cardinality, the sum of their cardinalities is basically the cardinality of the universe set. So this implies that we can find the cardinality of A union B from this. So cardinality of A union B will be then be the A intersection B is given as 20. The universe cardinality is 120. So A union B will have cardinality of 100. So and we know another set formula. Now we have found out the value of A union B, cardinality of A union B, cardinality of A and cardinality of B are given. So cardinality of A intersection B can be written as cardinality of A union B minus cardinality of okay, cardinality of A plus cardinality of B minus cardinality of A union B. This is a pretty straightforward set formula. You can see this from the Venn diagram also, the how this will be true. So this will be like 50 plus 70 minus 100, which is equals to 20. So yeah, this will be the answer. Okay, so someone is saying that you should equal 140 as 20 is also there. Okay, the total actually the group 20, this 20 is not extra people. What is given in the question is that there are total of 120 people. Like this 120 is not divided into this 50 plus 70 if you are getting confused. What the question is saying is that there are in total of 120 people, and some of those 50 of those 120 people like dairy milk, 70 of those like Kit Kat. By chance here the 70 plus 50 also comes out to 120, which is the source of your confusion. But the question intended to ask that out of the group of 120 people, there are different kinds of people. So 50 people like dairy milk, 70 like Kit Kat. It's not that uh, exact out of these, like this 120 is not divided into this 50 and 70. These numbers could have been somewhat different also, like this could have been 50 and this could have been 60. What this question is just saying is that the total set of people is 120, and out of those some of those like a dairy milk, some of those like Kit Kat, some of those do not like any. So is your doubt clear now? Like it was given as the total set of people, not just the people, not just the division of people into dairy milk and Kit Kat. Okay, sure. It's clear. Nice. So let's proceed to the seventh question then. So yeah. So which of the pair of sets are equal? I guess now it's getting a bit boring writing out the set. So I'll just straightforward write out the answer for you guys or by oral calculations only. So capital X is the set from 0 to 6, and capital Y is the set of all, capital X is the set of all integers from 0 to 6. So it will contain 0, 1, 2, 3, 4, 5, 6. But capital Y is the set of all real numbers less than 7. So since real numbers and integers don't have a correspondence, so X and Y are definitely not equal. Like Y is a very large set. Y is an infinite set because it contains real numbers and real numbers are infinite. And the option B is X, the set of letters in thymere, and Y, the set of letters in thymine. So these two are also not equal, X and Y, because you can see in Y, in the set Y, in thymine, capital N is also there, but there is no N in thymere. So B is also, so X and Y are not equal in B also. So option C is A is -2, -3, and B is the set of solutions of x square plus 5x plus 6. So this will be true. You can see that x square plus 5x plus 6 can be factorized as x plus 2 into x plus 3. So we'll get the solution set as -2 and -3 only. So A and B will be equal. So correct answer will be C here. is it clear to everyone? I just did it orally, but I guess it's a straightforward question. Okay, nice. Yes, it is clear. Let's just go to the next question, which is like suppose A is 1, 2, 3, 4. How many subsets of two distinct elements are possible? Okay, so here what we need to count is how many subsets of two distinct elements. Basically, we are given two elements like yeah. So basically, we are given a set of elements which contains 1, 2, 3, 4, and we need to make subsets of two distinct elements. So basically, out of these four elements, we need to select two of those elements, right? Because selecting any two of those two elements will be distinct out of these four. So answer will just be like from four, we have to choose two elements. So we'll get a subset of size two. So it will be equals to 4C2, which is equals to 6. So it's also a straightforward question. We just from like four distinct elements, we need to choose two elements and it can be done in 4C2 ways. So answer will be 6. So now let's come to the ninth question. So ninth question is again an application of De Morgan's law. So A intersection, the complement of A intersection B complement will be. So I'm just writing out the step here directly. It will be A union B because complement of B complement will be B itself. So it will be A complement union B and this whole in union with B. This was a parenthesis. And like since A complement union B, here there are two unions and union operations like can be taken out also. So basically what I'm saying is that union operations are associative, that this can be written as like it is some like every operation need not be like associative, but here union operation you must have seen in the set theory, like in the sets lectures that it is associative. So this parenthesis can be shifted to here also. So A complement union B, union with B can be written as A complement union of B union B. Then it can just be simplified to A complement union. B union B will just be B. So it will be A complement union B. So this will be option D. Right. Nice. Answer is D. Correct. So this is 10. So last question is very trivial. The set of O of odd positive integers less than or equal to 10. So we can just write this down. The set O will be equals to like odd positive integer will start from 1, then 3, then 5, then 7, then 9. So yeah, the answer for this will be 1, 3. 1, 3, 5, 7, 9. So nothing fancy going on here. So, yeah. So this was a straightforward question. So I'll not delve into this last question anymore. Okay, so guys, this concludes our session for the day. So I hope there are no more questions for anyone. And like yeah, thanks for tuning in and I'll see you guys next week. Hopefully I'll see you guys next week also. So yeah, I'll just stop the recording.